and the opportunity to talk to everyone today. I'll say I don't have very many real hands-on activities. I think I was a little more aspirational when I was planning this, but then spring break happened. So I will ask some questions and I will be watching the chat. So we will do some more kind of not like hands-on activities, but some of these sort of question and answer kind of activities where I'll hopefully folks will be engaged. And so, yeah, let's get into this. And I'm going to see if this works in terms of, oh, and I have a bunch of resources. I'm going to just throw these into the chat. I guess there may be a way to email them out afterwards, but these are, let's see if those pasted in just right. These are a bunch of really nice resources. I've stolen a couple of their slides, a couple of their figures. But if you want to go into more depth into some of these topics, these are really, really great resources. If you take a look at them, they're written at kind of varying levels in terms of your background, but some of them do go quite deep. What I want to do today, though, whoops, let's see if I can get back. Today what I want to do is in terms of expectation, my expectation is you don't know anything about conversational AI. You don't know anything about AI, you don't know anything about kind of programming or machine learning or anything like that. So I'm going to try to keep it fairly high level and mainly kind of motivate kind of what this space is all about, what I think is exciting about it. And we will talk about some real problems and kind of give you some directions on ways you can go forward. So the topic is conversational AI, right? And so naturally you wonder, like, what is a conversation really? And so if you Google for just the definition of a conversation, this is what you get. And I wanted to highlight a few words here. So first of all, you notice it talks about it's a talk. So that kind of indicates something verbal. Typically, informal. It's between people, two or more people, and something is exchanged between them. So when we think about conversational AI, take that as your sort of your foundation, but we want to kind of back out a little bit. And so I found this nice conversation from one of those surveys that I just put out in the chat. And what I want you to notice is there's still this notion of exchange. So here's exchanging information, but I want you to notice like who's doing the exchange, right? It doesn't have to be people. So in this case, it's generalizing out to humans or machines. That's the AI aspect of it. And the other thing is the traditional definition of conversation. We talk about talking and like sort of verbal. And so that could be kind of typed or kind of be verbal, natural language. But when we talk about conversational AI, it could generalize out to other kinds of interactions. So you could imagine the conversation could be between you and some kind of bot, and you're not necessarily talking to it, but you may be clicking things or interacting in some way. But there's sort of a natural back and forth between you and the machine. So that's the conversational aspect. It could be coming through these other kinds of modalities. So let's start out with a contrast of a non-conversational AI. So if you think about search is one of our great successes. And so if you go to Google and you can see the query up there, where is Texas A&M located? It does a really nice job. So I've communicated in some sense with the machine. The machine has come back, in this case, helpfully giving me the little info box, and it tells me exactly where it is. I don't have to actually I don't have to scroll down or do any more work. So the machine has done a really nice job there. But this idea of exchange, and sort of, you can imagine in conversation, there should be a back and forth. And so then I asked, is it expensive? That was the immediate follow query. And in this case, so Google doesn't know that it is referring back to Texas A&M. And so it's a video about being a girl or about being in Japan. It doesn't make any sense, right? And by the way, if you notice, this is like, I'm not signed in or anything. It doesn't know anything about my history. But even in that case, it's not able to connect it back to Texas A&M. This is non-conversational. This is not what we want. This is not what we want to have happen in terms of our interactions. If you think about conversations, think about it from the perspective of, here's an example of a conversational search, or you could think about it as a recommendation between the human and the machine. And so the idea here is more of the kind of interactions that we're going for, right? Can you find me a mobile phone on Amazon? And the machine would respond, oh, sure. What kind of operating system? And you respond, oh, Android. And you can imagine having kind of these interactions where now there is a dialogue between the human and the machine and potentially helps you arrive at what you want. And so in that case, The machine needs to be able to manage the state, where you are in the dialogue, if you're happy or not. It has to determine what questions to ask. It has to determine when it should make a recommendation, when it should continue to try to extract more information from you and what you're looking for. And this idea of kind of conversational, so like in terms of themes right now that are very hot right now, so this conversational search, conversational recommendation are very, very exciting. You also have something called conversational question answering. And so the idea here is, in this case, there's some text. Sorry, I can't annotate. This is really annoying. There's some text here about this governor's race. And the idea here is there's all of these works that are trying to learn how to basically figure out the right kinds of questions and the right kinds of answers that could be derived from this text. So in this case, it's like, what are the candidates running for? Oh, the answer is governor. And then that R is some sort of rationale or argument for why that is. And that was derived from the text. And so there's a lot of work right now on trying to basically take text, learn the kinds of questions that might be asked, learn how to answer them. And then the idea now is like, if anyone were to ever ask these questions, you now have text that supports it and you could answer those, like in a search engine, for example. But when you think about conversational AI, I'm sure a lot of us think about those intelligent assistants, right? So there's Alexa, Google Assistant, there's also Siri. And I think you mentioned this in the introduction, which is, a lot of us, when we get our devices for the first time, we use these a lot and we kind of play with them. But after a while, we kind of drop off and we don't tend to use them as much. And if you think about how you engage with these intelligent assistants, a lot of them, I would say, we're sort of in these very they're not really conversations, I would say. We use them to set a timer or play a song or ask about the weather. And the idea, though, is we're not having these like extended conversations with these machines. We're basically just kind of doing these sort of one-offs. I ask a thing and I get a response back. I ask a thing and I get a response back. But the point of all this is like there's a big gap between kind of the vision of where we'd like to go, being able to really have conversations, and kind of where the reality is. And the reality right now is kind of not great, I would say, right? It's like it's not great. There is, however, a ton of money being invested in these things. And so I'm sure a lot of you have encountered these kinds of chatbots, like on some website, a little thing pops up, or maybe in an app. And in this case, you can see it's basically like a slight extension of that kind of Siri or Alexa style, where the chatbots themselves have kind of a very limited working knowledge. And in this case, it's asking, someone's asking about an order. And the idea is, there's a couple of kind of canned responses. It knows how to get an order ID, look it up, and give some information. But the point is, you wouldn't expect to engage with the customer service chatbot very deeply, and you could quickly find kind of the edges of its capability. But there's a huge, in terms of kind of like the impact, there's a huge market in improving these things. And also like in healthcare. Healthcare is another really big space where, you'd like to be able, and again, you'll see kind of similar kind of canned abilities of these chatbots, where you can ask about, making appointments, you can maybe get some of your health information back and things like that. But the idea is it's still sort of in this sort of Alexa Siri model, and it's really not super sophisticated. And another kind of sort of, we talked about conversational search and recommendation, intelligent assistants. There's also just pure social bot. And these have been around for a long time. If you're familiar with Eliza and related ones, I think back from I want to say the 1960s. This is an example of a Stanford a social bot. This is purely a bot that you would want to go talk to. And this is actually a conversation I had with it, and I screenshotted it. And they want to know my name. I don't want to tell them. They ask me what I like to eat. I say lasagna. And you can see they're sort of like, oh, okay, you can understand. And then I didn't show the next screenshot, but basically it started to fail quite soon, because it said, do I like lasagna? And I said, I'd rather not talk about that. And it didn't know how to answer. And so that's part of the frustration I think we have, which is you're having kind of the semblance of a conversation, but then you find the edges of it, and then you get angry, and then you probably don't use it anymore. So the point of all this is we have a lot of work to do. So if you think about kind of conversational AI broadly, so if you're kind of new to this area, these are, I would say kind of 5 big themes, a big thrust. Recommenders, that's where the system is sort of guiding you to maybe a purchase, maybe some item you want to watch on Netflix. Search, I gave you the example at the beginning, this QA, social chatbot, and then more of the intelligent assistants like this voice command type stuff. So that's kind of like the big picture of kind of like when we think about conversational AI, this is where I think you see a lot of the research happening right now. And so what I want to do kind of now to pivot, and well, actually, yeah, and I'll pivot just a moment, but to kind of give you a sense of like how like generally these systems work, I grabbed a couple of screenshots from a couple of these surveys, and to kind of give you a sense of like when we think about these problems, kind of the generic approach that you'll see common across many of them is basically like this, which is, on the left-hand side, we see some human is interacting with this machine. There's some kind of language understanding component. And again, this could be coming from voice, it could be typed, but there's, or you can imagine even clicking certain buttons and so forth. But the idea is you're somehow trying to extract from the user, their intent, what it is that they want to do. Then you have some kind of dialogue manager. And within that, this is a really, really tricky part, is typically you're trying to manage the state and know where we are. So is basically the idea would be, is our user giving us their initial query, or are they revising something they said before? Are they changing directions? They want to try something different. And so the idea is we need to be able to track where we are in the dialogue, and so that every interaction is not just a one-off interaction. It's like when you use a search engine, typically there's not dialogue state tracking. It's just you send a query, you get a result back. Here, the idea is I say something, the dialogue manager responds, and it needs to understand where we are, how our dialogue is progressing, so that it knows how to react in the future. And so again, in a lot of these situations, what we're doing is on the very far right-hand side is we have some kind of data that's driving all of this. So this is very much the style of building these conversational AIs, is they're not being built from some sort of first principles about like a thinking machine, but typically they're being trained on large amounts of data from the web, from Wikipedia, from specialized resources that are basically being used to train these models. And so then the dialogue manager is modeling the state. It can then pick some policy, like what does it want to do? And then in this case, it has to then go generate back some kind of language, and this could be text or it could be spoken, that goes back to the user. And so I grabbed, this is from one of these surveys, and from a different survey, I want just to show you this is sort of generic. This is from a conversational search and recommendation context. And it's a quite similar framing, right? The idea is the user is somehow interacting. There's this NLU, this natural language understanding. And then behind the scene, there's this dialogue state management. And then under the hood, there's some sort of knowledge base, and that could be derived from the web or Wikipedia or whatever. And then this driving some kind of natural language generation, right? And so the point of the generation component there is, you can imagine the conversational agent maybe having to generate new sentences that it's never seen before, right? So we don't want to hard code everything that the agent could say. So the idea here is the agent may be having to generate some new sentences. Okay, so that's kind of the general framework of these things. Now, again, so what I want to do right now is basically, I've given you hopefully, like, I think this is a cool area. There's lots of exciting stuff going on. What I want to do right now is kind of pivot, and I want to talk about this Alexa Taskbot challenge. So this is actually a competition that a team from my group is engaged in right now. In fact, this is a critical week for us. Looking in the chat here, I think, or some of our participants, some of my students might be here. This is sort of a critical week for us in this competition. But what I want to do now is, instead of giving you just sort of a generic introduction to conversational AI, I want to talk about conversational AI in the context of this Taskbot challenge. And so I think what's interesting about that is I can give you kind of more kind of concrete examples of like real problems we really face. And then hopefully it'll kind of motivate you to think about kind of like next steps in this area. Okay, cool. Also, I'm still watching the chat. So if you have any comments or questions, or if you just want to say anything, go in the chat. I feel like a Twitch streamer, so sometimes I can watch the chat and respond. Okay, so let's anyway, the point is we'll talk about this Taskbot challenge and we'll see a bunch of the challenges that we face and some of the ideas that we've had as a team to tackle those challenges. So what is the Amazon Alexa Taskbot Challenge? So basically, it's a 1-year competition. So Amazon has run, I think this is maybe the 3rd or the 4th competition. This is the first time they've done a Taskbot. So in the past, they've done like a social bot. So can some bot engage with humans? In this case, we're actually building a conversational AI system that can help users do it-yourself task or do cooking, okay? And so Amazon said, 100 teams around the world started an application and they picked 10, okay? And that's where we are. This is worldwide for the challenge. You can see there's Texas down there. These are the 10 teams. We're one of the 10. And you can see our friends at Carnegie Mellon and Ohio State and UCSB, et cetera, et cetera, et cetera. So we're all in this big competition. And this is our team right here. Some of us here virtually, but we have a nice team of grad students and undergrads. And we've been basically working on this since I think we got under contract in June. And we're heading closely to the finals soon. So basically it's structured like this. So like in May, they announced the teams. We had the summer to basically build our initial Taskbot. And then you can see in the fall, the competition actually began. And we were actually put in front of real Amazon Alexa users. I'll talk about that in a second. And right now we're in March and we're heading towards the finals in May. And so why do we care about this? Why do my students care? It's money, right? We don't do things around here purely for the intellectual pursuit, but we do it for money. And so the first place team wins $500,000. And no, mind you, I don't get any of that money. That goes straight to the students and is evenly divided. Second place gets 100K, third place gets 50K. There's a question in the chat, which is how are the teams selected? We don't know. So we had to write a proposal and basically talk about some of our technical approaches, some of our ideas. But then Amazon ultimately, they just announced these are the 10 teams. So I'm sure they impaneled a scientific committee and made a decision, but we didn't get any feedback. It was just purely yes or no. And so so we're in it for the money, and okay, we're in it for the fun too. It is fun. And so just to kind of give you a sense of the timeline. So the fun part about this is like I'd never even heard of this. And so if you look at my background, I'm not actually a conversational AI person. Okay, this is one of the fun things about doing research. But in March, I was talking to, So you says, it was a competitive process. That's right. Yeah, that's right. So in March, I was actually talking to a prospective PhD student who had actually participated and actually won in a previous instantiation as a master's student. And so that was the first I heard about it. So we threw a team together, said, let's go for it. We threw in our application, we made it. And it moved very fast. So in the summer, we had to learn about Amazon's infrastructure and basically ship something that could basically interact with humans. You can see in August, we were actually in front of Amazon testers. So one of the things, there's lots of like legal concerns. We don't want to help users do anything dubious, anything dangerous, anything that may be illegal. And so there's all these checks that you have to make sure that we basically if a user asks for any of these dangerous or illegal activities, that we basically say we can't do it and we kind of get out of the conversation. And anyway, by October, we had to have like certain kind of quality metrics. And then we actually graduated to real users. And then the quarterfinals began in December. And so and then you can see where we are. We're in the semifinals, which ends actually later this week. And what's happening is, we have these conversations that happen kind of like this. So a user comes to us, says, I'd like to make a chocolate cake. Oh, sounds great. I found some great recipes. They say, sure, okay, we can go ahead and begin the task, preheat the oven. They say, okay. Now we go over the ingredients. And so you can imagine like there's now a task. This is not a pure just social like chit chat bot. The idea is the user is driving towards a task that they want to complete. And our job is to help them do it. And so the thing is, if you have an Alexa device, so if you have one, you're welcome to use it like today. And so if you say to your device, assist me, or if you say, let's work together, that'll launch this Amazon response, which will basically say, look, this is part of the Amazon Alexa Taskbot Challenge. It's a research challenge. And then they'll randomly pick one of the 10 teams. And so you don't know which one you're going to get. Then you'll have an interaction with that team. And then when it concludes, then Amazon will come back and basically say, would you like to give a rating to the interaction or not, 1 to 5? And so this is live in front of real, like anyone around the world who says assist me or let's work together. You're going to be using one of these 10 Taskbots, okay? And again, this random process of how they pick. And so that's how we're being judged, is on those ratings from real people. So before I move on, I just want to say this is like, if you've done, I'm assuming most of you are kind of, researchers, or you're thinking, you've done some research. Typically we work in, we have some beautiful like offline data set, or we have some sort of theoretical model of the world, or we're going to kind of prove some characteristics of some algorithm. Here we're interacting with real people. And let me tell you what, real people they're strange. They have a wide variety of interests, and it makes this a very, very big challenge. Okay, so I'll show you some examples about like why this is so hard. But the point being is people don't act like we want them to act. They're quite random. So thanks to our team lead, Majid. This is the overall architecture. And I guess I haven't told you, the name of our team is Howdy Y'all. And so what you're looking at here is basically an overview of our architecture. Don't worry too much about the details, but I just want you to see this kind of correlates with those architectures I showed you earlier, which is, you notice there is a dialogue manager, which is and then in the middle you see the state manager. So the idea is we're managing like where we are in the conversation. This dialogue manager, you notice it says selecting strategy, ranking, and response builder. And so the idea here is some utterance comes in from the user. They're asking us something, right? The state manager is trying to figure out where we are. Like, are we beginning? Are we sort of in the middle? The dialogue manager is now figuring out how do we respond, right? And so you'll notice in the middle, it's something called response generators. You see there's recipes, there's DIY, there's chit chat, there's help, there's some utilities, there's lots of these components. And so the idea is basically as we're moving along, we're in parallel running all of these response generators. We then are trying to rank them to figure out which one we think is the most appropriate. Because the other thing we have to keep in mind, this has to happen fast, right? So when the user talks to us, we can't go offline and spend 30 seconds or a minute. You can't even spend 5 seconds. You're sort of thinking about the answer. They have a latency requirement. So the idea is they hit us, we better start running in parallel all of these possible responses. We pick the one we think is most appropriate, and we go back to the user, and this cycle continues. So what I want to do now is just walk through some of the real challenges we faced. And I notice, everyone's being quite quiet. So I'm going to have some questions for you in just a moment, which maybe you guys will fire up in the chat. But what I'm going to do is walk through, I think I've got like 5 or maybe 6 of these challenges. And just to talk about like real challenges we face, and I'm gonna give you a flavor of some of the technical solutions that we're deploying, and kind of some of the open questions, or like where we're trying to go with all of this and why it's so hard. So the first one is on this ASR side, the speech recognition. So the challenge is not actually in building that. So the good news is Amazon does this for us, right? So we never actually hear the voice of our Amazon users. Instead, Amazon turns the voice into text, and they just give us the text, okay? And so what happens is basically, we have these conversations that look something like this, right? So we're in the middle of helping you bake a cake, and we say, okay, the first step is, preheat your oven, and you say next. We go to the next step. And so you can imagine from your dialogue state manager, this is quite simple. Like we know which step we're on. If the user wants to proceed to the next step, then give them the next step, and we keep moving along until we finish the job. But the problem, of course, is that users don't always say next, right? They say, so yeah, here like in code, what this might look like is, some function that decides what to say, and it says basically, if the user says next, and we're on the first step, go to the second step. Now, of course, we're not going to do something, we're going to have to we're not going to hard code it to this degree. But this is kind of the idea of how this would work. Okay. But the point is, of course, users don't say next. Sometimes they say desk. So why would they say desk? Or they don't say desk, they say best. Or they say let's. Or they say list. Yeah, so Cameron says mistypes. So it could be mistypes, but in this case, these are all voice interactions. So what's happening is Amazon is transcribing the words they say. It's turning the voice into text. and it's saying the person said desk or list. So it's not a mistype, right? But it's an error that's happening. Presumably they're not actually saying desk. Now they could be saying desk, but presumably they said next. But somehow, remember Amazon, we have who's using these devices. It's basically all ages. You have native and non-native speakers. You've got people with any kind of speech issue you can imagine. So it's like a very wide range of languages coming in. And so, yeah, so basically what happens is the code doesn't work anymore, right? It's sort of simplified version of, hey, they didn't say next, so what do we do? And what we've discovered when you deal with real people is that if you fail, if you said desk and we say, we don't know what to do, I'm sorry, they hate us, right? And they give us a 1. Or if we say, I think you said desk, and then they say next, and then Amazon hears desk, and we say, I think you said desk again, they're going to get really, really mad, right? And they have a bad interaction. And this is one of the reasons, right? We have kind of this loss of trust, and no one wants to use Alexa anymore. So what's going on is basically, right, so we have the speech to text, or this ASR, this sort of waveform comes in, we hear next, we run the code, and what happens, right? And then all we're doing is we generate text that we give back to Amazon, and then Amazon turns that into speech. So we don't do that part either, right? So the point is like what's happening is we're not touching the ASR component. So the idea is people are saying next, but we're not getting the right words. And so we can't actually fix that part because Amazon owns that piece. And so instead, right, we don't have access. So we have to somehow fix it in code, not in the actual ASR. So the point here is like, we hear desk, we have to somehow still operate on that. So ideas, I'll push this back to the chat. Any ideas on how we might deal with this problem? Now, mind you, we cannot go into the ASR. We can only deal with like desk, let's, list, next, all these kinds of things. Any ideas on how we might deal with that? I'll look in the chat, or you're welcome to just call out if you want. I'll give you guys just a second. I can feel the excitement from all of our. Move forward unless instructed to go back. Yeah, that's when let's go from the top here. This is great. When you hear desk, yeah, somehow try to map it to next, right? Sounds the same. It sounds like is a good idea. One is essentially, Reddy says basically kind of almost like ignore it. They said something short, something reasonable, just to assume they said it and move on. Tian says, yeah, we could ask them for a confirmation, and we have done that style. And then our users actually get quite mad. Laren, similarly, just assume they said it and move on. Maybe split the words up. Yeah, so you guys have a lot of great ideas. And it's essentially, this is a lot of what we're doing, right? So the first idea, right, is we can basically just, cook up as many words that we know sound the same. So like next, desk, bets, let's just go hard code all of those and do that, right? And you can imagine the advantages and disadvantages. Advantages is very simple. Disadvantage, we may not enumerate everything. They may say something outside of the scope of all of this. So that's not going to work. I mean, it is a start, and we do this. Like another idea in terms of like a similarity checker, it turns out there's lots of tricks for this kind of stuff. So one of them is called SoundX. It's been around for forever. And SoundX is basically a way to try to basically turn words that sound the same into essentially some sort of like a canonical form, so that like words that sound the same will get mapped to something similar. And so you can see here, there are these, in fact, I'll show you, this is the algorithm right here. This is like a very simple thing. But basically you keep whatever the first letter is. So the idea is, the hope is that the first letter is right, okay? And then for everything else, you basically take you can notice all the vowels get mapped, disappear. And you're basically looking for all those hard sounds. So like B's and F's and P's and V's, they all get mapped to the same number 1. Like D's and T's, they get mapped to a 3. So the idea is like we're trying M's and N's sound alike. And basically, this is like one way with soundex is you transform. So in this case, like Robert and Rupert, right? Those are different words, but they kind of sound alike. And so you notice in this world, you keep the R, all of the vowels disappear, but like the B and the P both get mapped to 1. The R's get mapped to 6, and the T's get mapped to 3. And so this is like one way. It's a very kind of hard-codey way, but it's one way to begin to map. So you would see, oh, Robert and Rupert match to the same soundex encoding, and you can now say they're the same, right? It's just one idea. And so, in fact, we are using this. We've tried this. Again, this has some problems because, like we've seen before, like if the first letter is off, so we have desk and next, those are mapped to different, because the D and the N, you keep the first letter. And so soundex is not going to work there. But this is kind of an idea of some of the tricks you might have to do. So in terms of like, sort of this point about clarification questions is we have done this. So we'll see things like, we hear star cooking. One of the funnier ones, I'm not sure if Majid is still on here. One of the funnier ones we had is they say start task. That's one of the things they say to us. Like you say, oh, if you'd like to start the task, say start task. And we hear that sometimes as fart task. So that's not great. And so when we do things like this is basically we would say, for star cooking, we might say, did you mean start cooking? And yeah, users tend to get really annoyed. So back to, I think Reddy and some other folks mentioned this. So a lot of times, even if we don't have an exact match, we'll just sort of silently assume they said the right thing, and we'll just keep going. And if they tell us to stop, then you can always back out and try to fix it. So then one of the things we really like to do is like, sort of machine learning is always the answer to these things. We'd like to do like a more kind of principled like ML approach, but you need data. And so one of the things that we've been doing is we have like this whole history of conversation. So we have all of the logs of every interaction we've ever had with these users. And to go back and see, like whenever, like for those next intents, like they want to go to the next step, let's go hand label every version of what they've ever said, and then try to use that to then try to build a model to better understand what it is they're doing. Okay, cool. So that was just kind of like one of the sort of getting to know this problem space challenges I thought I'd start out with, because to me it's kind of fun, and it just shows you, again, users are really, I don't say weird, but they do lots of things that make your life difficult. Okay, so the second thing is actually the way these are constructed is I mentioned before is typically you have like you have some kind of data set that supports the kind of task that you can do. And so one thing that we have happen is we're using something called WikiHow. This is determined by Amazon. And so what happens is when a user says something like, help me clean my bathroom. Okay, our knowledge base is basically, we can go search on WikiHow and see if WikiHow has articles. And if they do, then we can go give it to the user. And so it turns out there is an article from WikiHow that says how to clean your bathroom fast. And if you go into that article, you'll see that there are steps, like step 1, gather up any trash. And then there's all these details about how to do that step. There's a question, is Amazon allowing us to collect the data from these interactions? So yeah, so basically what I cannot include any of those interactions in this talk. So I'm limited from revealing any of those interactions. So all the interactions you see in the talk are all kind of contrived, but they're based on kind of real interactions. So no, we have logs. We see every conversation from the user. So everything they say, everything we say, and we have the whole log. And we're allowed to analyze those logs and use them to update our Taskbot. But we're not allowed to publish them or do anything more with those interactions. We had to sign a bunch of paperwork about this in terms of like publications, right? Because we'd like to publish, we build some fancy model. We'd like to be able to publish it, maybe use some of this data. And for any of those kinds of situations, we'll have to get publication approval from Amazon before we're allowed to do it. But I'll just say, for me as a researcher, my whole career, it's like typically I'm never seeing this kind of data. So it's like extremely stimulating because you see all sorts of weird stuff that kind of motivates interesting research questions. So yeah, in this sort of this WikiHow world, so you can imagine, if again, the query or the user says, help me clean my bathroom. We want to go to WikiHow. There's a beautiful article about it. And so it already has the steps. And so you can imagine we'll just say, okay, hey, first you need to gather up any trash. Let's move on to the next step. But then if they say, oh, how do you gather up trash? Well, we have all of this text here that we can use to support like a query answering model to give them more detail, right? Oh, yeah, so like, how do you clean up your trash? Well, look for the, empty the trash can into a plastic garbage bag. Who needs help doing this? It's amazing. Blah, blah, blah. But we have more like kind of text and sort of knowledge that we can use to do this. But the problem we face is, again, some of this is kind of just a pure engineering problem, but I think it's kind of interesting, which is we're using kind of a default search engine from Amazon. So we don't have, or historically, we haven't had all that WikiHow data. So we can only access it via some API. Okay. The problem is like the search that they have is not very good. So let me give you an example. Like this is a real example. So if you use their sort of default search engine, you say how to clean my restroom. We take that and we throw it at this WikiHow API that Amazon gives us. It'll come back and this will be the top 5 results we get. Result number 1, how to overcome public restroom embarrassment, right? Number 2, oh my gosh. Number 2, how to use a public restroom, right? And so somehow it's matching on restroom, but none of these results are very good. Maybe the 5th one is okay, right? How to clean bathroom tile, but even then that's not really what the user is asking for. And so the problem, of course, is our whole Taskbot, like its whole like knowledge base is based on this search. And so what happens is, if you say, hey, how do I clean my bathroom? We say, oh, I looked at WikiHow. Here's the best result. User's going to be mad because it doesn't match what they want. And they'll say, no, this is not what I want. And then maybe we finally get to it a few batches of 5 later, but the user's annoyed and they're gone and we're going to get a bad rating. Another one, yeah, this one's like, how do you draw on a wall? And again, you can see how to draw a brick wall, how to draw WALL-E, the character from Pixar, and all these other kinds of problems. And so the point being is that if we just go with their out of the box search engine, we're in big trouble. Okay, so we got to do something better. And so, right, we don't want to just do the strict keyword match. So restroom matching with restroom, right? We want to understand kind of more of the context of the query. This is classic kind of search engine problem. We want to be able to handle typos, variants. We want to be able to handle synonyms. And so, the idea here is we're using something, if you guys are familiar with Bert, and so I'm going to do a brief introduction to Bert here in a moment. But the idea is we're going to basically use, we're going to index some richer representation or a vector representation of these WikiHow articles. And so we're using something called sentence Bert. And then we're not, and Reddy says, we're not allowed to use Google search. No. So we have to roll our own. All of this is our own stuff. There are all these restrictions in terms of which data sources we can use, which APIs we can use, and so forth. Because you're right, Google does a really good job on this kind of stuff. We can't use it. So we basically have WikiHow, and then we have like their recipe API. And so we can access all of these articles and all these recipes. And then with that, we can basically build our own search engine in essence. That's what we had to do here. And so the idea is so let me just show you. So if you're familiar with Bert or you're not, so the idea is we're using these embeddings. And so, yeah, I'm sorry, I can't annotate, but typically, you can imagine you would represent every word by just some sort of like one hot vector. And so you can imagine like this incredibly long vector, like it's the size of your vocabulary, which could be like millions or billions of tokens. And bathroom is like one of those, right? And so you can imagine setting up some kind of, and you could try to do some different kinds of weightings, but you can imagine doing some kind of, if the query mentions bathroom, and then you have all of these documents and the titles, you can do some kind of similarity between the query and the document. by looking at some kind of these like very like sparse vector representations. So you'll see, oh, they match in terms of bathroom, then we have a hit and you get some kind of score. Alternatively, you can use what's called like a dense embedding. And this is very much like the hotness these days. Google search has basically been rewritten to take advantage of these. It's basically like kind of the de facto models that everyone is using. And so the idea is you now have like a dense embedding. So the idea is you have like this much smaller dimensional vector, but you somehow use some sort of learning process to learn that the bathroom is this particular point in this vector space. And the idea is like bathroom and restroom would have similar representations in this embedding space. And why would they be similar? Well, because those words are used interchangeably in lots and lots of documents. And so this idea of like trying to learn those embeddings is very much like, very, very exciting. And everyone's doing this stuff right now. So this Bert is one of these things. And basically it's a way to learn these embeddings that are really high quality. And so you may have heard of these, are called pre-trained language models. And so they're trained over like millions and millions and millions and millions and millions of documents. And then we can use them off the shelf because they now give us these rich representations of all of these words. And so this is the article from Google, Bert. This is 2019. And I'm just telling you, in a few years, this thing has had like, it's like an earthquake. And the idea is if you're familiar with Word2Vec, so I'm not going to go too deep in all this stuff, but like when sort of 10 years ago, kind of Word2Vec was kind of the de facto word embedding model people were using, which was the idea you basically are going to learn how words are used in sentences. So you train it over lots and lots of sentences. But the point is it learned like a single word embedding for every word. So this point here, this is a classic example of something like bank would have the same representation regardless of the context. So like a bank account is fundamentally different from a riverbank, but that bank would have just a single representation. And so what Bert is doing, it allows you to learn these contextual representations. And so like a bank account has a particular kind of representation, which is different from a riverbank, right? And so now you have sort of these richer representations. And it's kind of launched, sort of launched a million ships. And this point of, so what's nice about Bert is that it like super generalizes to lots and lots of tasks. So I'm going to tell you a little bit more about this later on. But the idea is you basically go take one of these really big pre-trained language models, and then you can essentially sort of optimize it for the particular task you want, which is very, very kind of simply and very kind of quickly. And what's nice about that is you basically can bring all of these kind of world semantics. So when we talk about conversational AI, right, it's like we want to have models of the world. And so rather than doing some kind of like, sort of building some ontology, and we understand the relationship between all these concepts, the sort of BERT model is, no, just go build these really, really huge pre-trained language models from lots and lots and lots of documents. And then the hope is they encode lots of kind of domain and world knowledge in these embeddings. And mind you, the number of parameters these models have is just humongous, hundreds of millions of parameters. And then the hope is, right, rather than building sort of like this ontology, you use these pre-trained language models to then help you drive all of this stuff. So, and again, this is just all kind of background of BERT. And so I'm kind of showing you this. So if you don't know about this stuff, this is like an exciting area. And even if you're not like an NLP kind of person, you can bring very like heavyweight, cool, kind of cool technology to the problems that you're facing right now. And you can really go a long way with this stuff. So just to show you an example here. So Glue is like this like suite of task. And so the point I'm trying to show you here is like all of those columns are different tasks, okay? And so the point is like by shifting from some of these traditional models to a BERT-based model, suddenly you're winning on all of these different tasks. So the idea is you're not really building like a custom model for every task. You're building like a single model that then you're doing what's called fine tuning. But the idea is that sort of one big model can now help you tackle all of these different tasks, okay? It has big, big improvements and kind of, again, is really inspired lots and lots of work. And so this is a picture from a couple of years ago, but again, just to give you the sense of like this BERT world. Yeah, so you says, is BERT what Google is currently using? They are certainly using some variation of Bert. Probably not the original Bert, but this idea of these big pre-trained language models, absolutely, it's all throughout their products. So you can see we have Bert. Then there's like all these variations. Roberta. I don't think there's Distill Bert. This whole like panoply of Muppets. You see lots and lots of these kinds of big pre-trained language models. And this stuff is absolutely like just a huge change in how we think about lots and lots of any problem with text. These pre-trained language models are right there. It's just totally changing how we think about these problems. And again, bringing huge improvements. So I just want to give you a flavor of that. I'm gonna come back to this a little bit later, but the point being is that if you're not familiar with this stuff, it's really exciting. There's lots and lots of opportunity here. And so basically what we're doing is we take all those WikiHow titles, then we're using something called a sentence BERT to then encode them. So now the idea is just because it has the word bathroom, right? It's now going to have some representation. So it's also going to be near restroom. And so if the WikiHow title is about cleaning a bathroom, that's going to be near in this sort of vector space, something about, I don't know what's another word for cleaning, but like, making neat my restroom. So those, even though they have none of the words in common, the hope is that they're going to map to similar points in this vector space. So when the query comes in, it's also encoded with this sentence BERT. So then you can do a similarity calculation between the two. And so not to be too boring, but like just to show you some examples. So if you say how to clean my restroom, if you're just doing a keyword match on the left-hand side, you can see those are those kind of crummy results. But on the right-hand side, now we do get good. The first result is how to clean a bathroom. So notice it's bathroom, not restroom, but those are similar in the BERT, kind of the sentence BERT vector space. And you can see the rest of the results, how to clean a bathroom sink, right? So these are all like in the neighborhood, but the first one is really good. How to color my wall, again, on the left-hand side, you can see it's okay. But on the right-hand side, color a wall, okay, but that's close by to paint, how to paint a wall. And we have a bunch of other examples. And typically you want to, if you can give them a good result on the first one, they're going to be happier, right, than giving them like a big list. How to draw on a wall. This is like Wall-E. And again, in this new world, how to paint designs on a wall, how to paint a wall, and so on and so forth. So you get some really nice results out of that. And we did a little in-house experiment, because the other thing is like we're not Google, right? And we only have these user interactions. So back in the fall when we were first working on this, we did a little homegrown experiment where, in this case, NDCG is a metric sort of higher is better. It's a metric of goodness of the results, same as in mean ranking position. The higher you are, and fail is how many times we just totally don't have a good answer. And so we hand labeled, I think, something on the order of like 60 or 70 of these user queries. And you can see here, like the NDCG goes up to 1, we get a big improvement in the quality there. Our mean rank of like the good solution goes up. It's not great, but it's still better. And we fail much fewer. So it's not perfect by any means. But the idea is we're kind of heading in a better direction. Cool. I'm still watching the chat, folks. You're still sticking with me. Let's do one more, and then we'll take a break for a few minutes. So the next one is about user intent. So this is the main idea here is users come to us and we get their utterances. Reddy says, is Amazon okay with you using Google BERT models? Great question. So yeah, so basically there's something called the hugging. So basically there's a lot of these big pre-trained language models that are now, they're basically almost like open source. So there's, if someone can throw it in the chat, I don't have the URL in front of me. There's something called Hugging Face that someone can go Google that or throw that into the chat. But basically, there are these really big pre-trained language models that are essentially kind of open source and anyone can use them. And so, yeah, absolutely, Amazon's fine with it. Yeah, I'm sure Amazon internally is using all of this stuff. Again, my hunch is, Google internally is using some big pre-trained language models that are not public, that we don't know about, but there are versions that are public that we do know about. And yeah, absolutely. Everyone's using this stuff. It's totally fine. So yeah, thank you, Shangju. This is also, if you're into this kind of BERT stuff, if you think this is kind of a neat area and you don't know much about it, Hugging Face is like this really, really amazing resource. They have tutorials. They have you can do all. In fact, you guys are going to make me go do it. Hang on, I'm going to stop my share for a second, and let me see. Because to me, this is, let me share this thing. Yeah, so this Hugging Face. Yeah, you can see basically they have all of these, like there's BERT-based Chinese. This is like a particular model. This is a variation, Roberta base. So if you click into here, this is a pre-trained language model. And Roberta, let's see, it gives you gives you how to use it. It gives you code on how to get it. And let me think what else it has in here. It tells you like how it was trained, right? It was trained on books, all of English Wikipedia, there's news, it tells you all of this. So it's 160 GB of text that was trained on. It gives you all these nice results. And so you can go grab all this stuff. And then if you come in here into, is it not in here? It's not in data sets. I don't have it, I can't see it right here, but like the tutorials. But basically they have like these nice tutorials that will walk you through how to use this stuff. And so I'm not seeing it right now. Maybe someone else can throw me a better link. Whoops. Yeah, someone's throwing it in there. Beautiful. Thank you, Karthik. Yeah, even better. So yeah, so basically if you go in here, yeah, so Karthik just threw in this link. This is a whole course on like, what are these big models, these transformer models? How do you use them? How do you fine tune? We'll talk a little bit about this later, but like it walks you through the whole thing and it's like super, super nice. And so if you want to use any of this stuff, it's like basically kind of off the shelf with all the kind of the code, all of the kind of the steps you need. And then once you've got that, you're in great shape and you can start using this stuff. Reddy says, I'm guessing you can download these BERT models and run them on your own computers. I guess you're running on the, yeah, you can absolutely get them. Yeah, you can run them locally. You can run them on AWS. Let me find, yeah. And I think I see in the chat even more good stuff. Yes. Google now has MUM, which is 1,000 times more powerful than BERT. Okay, well, it doesn't stop. So the stuff, but the point is, if you're doing anything with text, like you want to be using one of these models, basically with very little effort, you're going to be doing way better than any kind of like traditional method. Yeah, I mean, that's pretty much the big takeaway. Let's do this one little bit here and then we'll take a break. So intents. So, okay, we have utterances. Utterances are like what the user says, next best, or how to clean my bathroom. So that's an utterance. But obviously one of the key things is we need to figure out, how do you map that utterance to an intent? What is it the user wants us to do? What is the action that we want to take? So you can imagine intents are like next intent, which is there's lots of ways to say next, go to the next thing. But what they're really trying to do is like, there's some sort of intent. They want to go to the next thing. So we have to map all those utterances to this action we should take. Or like the start intent. You're ready to start a task. You may say, let's go. I'm ready. Come on, let's start. There's all these different ways the utterances could come in, but we want to map those back to some action that we should take. Okay, Reddy says, can I talk a bit about the contractual agreements with Amazon? Yeah, so we had to sign a bunch of stuff. It took forever for legal to take care of all this stuff. So I want to say, like, in a nutshell, I think all of our code, I can't remember exactly what we have to give to Amazon. Do we give them everything? We certainly give them a description. We have to tell them kind of like scientifically, you know, what were the methods we took, formulas and whatnot. I think they have all of our code. Anything we want to publish off of this, Amazon wants some pre-approval to make sure, and they're very concerned that they don't want us revealing any customer information. But my understanding is kind of aggregates should be okay. You know, like if, but we couldn't publish the data that we've been collecting, for example. What that means is any kind of research we do, we would have to make sure that we have a public data set, and then we could also mention we have a private data set, but we couldn't share the private data set. Beyond that, I mean, we signed a bunch of stuff already. I don't know all the details, but yeah, it took forever to get that stuff under contract. Who's paying the students? Yeah, so basically, oh yeah, so Amazon, yeah, they funded us for the year. So we got like $250K for the year. And that's structured just like a regular like NSF grant. You know, there's overhead and all that kind of stuff. And then I use that. I pay some graduate students. We pay some students hourly. Some students are doing it for credits and things like that. Yeah. Okay. But yeah, there is overhead. Don't worry. There's all that good stuff. Okay, so we got a bunch of intents. And so here's a challenge for the audience. So we say, okay, step 3 of 9, add the olive oil to the pan. And they say yes. What intent does that map to? This word yes in this context. What does the user expect to happen? I did it. I'm finished. Go on. Give me the next one. Next intent. Let's keep going. Sure. So go to step 4. Don't acknowledge. Don't tell them I heard you said yes. Does that mean? Just go to the next one, right? How about in this case? They say I don't have olive oil. What intent should that map to? Presumably not the next intent because there's a problem. Maybe a substitute. Yeah. So we could do, hey, so we need to have some knowledge about, you know, maybe butter is a substitute for olive oil. Okay. Alternatively, this is Amazon. So if they say, I don't have olive oil, what else could we suggest? Well, we can go buy it for you. Yeah, you can say, go buy it. Yeah. So do you want to put it on your shopping list? Right. So that's a different intent. It's not the substitute intent. That's like the add to shopping list intent. And it's not clear to me which one is the right one. And so a lot of this is human behavior, and it's like trying to deploy this stuff and see how our users respond. So if they say, yes, put it in your shopping list, boom, 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 boom. So now given the user utterance, or maybe this history, you want to map the utterance to the intent. How are we going to do this? So if they say yes, that's a next intent. Or they say, I don't have this, that's a substitute intent, right? How are we, any ideas, folks? Yeah, we can definitely look at the chat history. We're trying to get them to the finish of this thing. So for sure, we're going to keep moving on. We want to complete the task. But when they tell us, like, you know, come back here, whoops. When they say yes, we need to know that means next intent. And so earlier we talked about kind of hard coding this stuff, right? Yes, next, let's, something like that. We can definitely hard code this stuff. But you also have cases like this, like I don't have olive oil. Maybe that spawns a substitute intent, which then says, You can substitute butter. So we have to figure out kind of what we're going to do in these cases. So the approach that, one approach you can take is to use Bert again. And so the idea here is you can turn this into, for example, you could turn this into like a multi-class classification problem. So the idea is we have some inputs and let's say I have 10 different intents, right? Substitute intent, next intent, start intent. And so you can imagine, given an utterance, it's a classification task. Which one of these 10 intents is the right one? And so that's exactly what I think we've deployed this. I think we deployed it this weekend. This is one of the things we've been working on most recently, which is then turn this into a classification task. But if you remember, so the way Bert is structured is someone else has already done this pre-training. Okay, they've already pre-trained, which takes a really long time, and it's trained over lots and lots of documents. And you and me, we don't want to do the pre-training. And so what happens here is, like for original Bert, right? It's like 800 million words from book corpus, 2.5 billion words from Wikipedia, trained for days and days and days on like, this is all expensive to do. You and I don't want to do this, right? If you're doing it on some GPUs with 8 GPUs back then, it could take you a couple of months to train. So we don't want to do any of this pre-training, right? So we're not going to do that. So the idea is you go to Hugging Face and we can get the pre-trained model, okay? But the point is the pre-trained model doesn't help me necessarily do the task here, right? So then you want to do what's called fine tuning. So the idea is I take the pre-trained model, okay? And then basically I can just do some fine tuning, which is run a few more epochs afterwards, where basically what you can do is you can take Bert. We have all these pre-trained language model, right? We have all of these embeddings, and you can basically add one more layer on top of it, right? And then you can basically, if you're going to do like cross entropy loss for like a classification task, and then you can basically then say like, I now have some training data for this like multi-class intent classification problem. Okay. So then you do this fine tuning where now you basically update those parameters for a few more epochs to fine tune on this particular downstream task, in this case, intent classification, and you're done. Okay. So that's why this is like very generalizable, this idea of like, you take Bert and now you have all of these different downstream tasks, sentiment analysis, in this case, intent classification, all these different problems, they all start with the same foundation Bert model, and then you fine tune, which is a very simple process on the downstream task. So so fine tuning is super fast, right? It only takes a few epochs, and the idea is like, Bert already has learned all this general language knowledge, so it's already kind of very rich. And so it just takes a couple of steps to optimize it for your particular task. Okay, so again, if you have any kind of text classification problem, take Bert, then fine tune on a much smaller set of labeled data for this particular task. And you're going to do way better than if you just build a model purely on the little bit of ground truth data that you already have, right? Because the whole idea is you're bringing to bear all of this kind of general language model from all this Wikipedia in the pre-trained language model itself to help you do this, okay? So the main thing is you don't want to pre-train, as you and me, as just regular people. The fine tuning is fast. Go to Hugging Face, look in the chat. You can go grab one of these things from Hugging Face, and then you can go fine tune on whatever task you have, okay? And so what I'm showing you here is just a preliminary result we have from doing this, where what I'm showing you, this is the accuracy results of this intent classification using this kind of Bert model. And what I'm showing in the context is essentially like, are we taking in the previous 10 utterances? So a turn would be me, then you, me, then you. So I can pack all of that stuff up. Or I could take the previous 6 or the previous 2. So I have different amounts of history. And then do we take in the labels of those intents before? So we've hand labeled a bunch of these things. Don't worry too much about the details. But what's nice about this is that, like, if you look at just like a popularity baseline, if you just predict the most popular, that's that 36 number at the bottom, like your accuracy is like 36%. if you randomly pick one of these, it's like 5%, or up to 20%, depending on how you pick it. But just using this sort of off-the-shelf BERT model, fine-tuned on a bunch of intents that we've labeled, you can get in the order of like 80% accuracy. Okay. And so what's nice about that is, again, if you're in the middle of someone saying, hey, I got a substitute, I don't have olive oil. We don't have to hand code a rule. We don't have to do any of this. We just throw it through this model, and it's going to hopefully output, oh, this is a substitute intent. And then you then go fire off the substitute responder. Okay. Tian says, did we fine tune all the layers of BERT or just the first few bottom layers? So this is just fine tuning at the end on the last layer. But these are results I literally just got like 2 days ago. So I'm assuming that's all he did, but I'm not sure. But Tian, send me email offline, and I can get you in contact with who did this piece. Okay. You guys want to take a break for a few minutes, or do we want to power through? Or we could take a break. I leave it to you. Can I run a poll?
James, if we can get it down 3:30, 3:40, probably we can just keep going.
Okay, cool. So we're going to power through, folks. Reddy says, how many customer interactions do we have so far? I'll tell you. I think that's not proprietary. We have our own dashboards. I'm looking at it right now. We have, this is only in the semifinals. We have about 1,100 interactions in the semifinals. So however long that's been going on. I think it's 1,000 for the semifinals. Let's see. So it's a lot. Semifinals only. No, I think this is 1,100 total. I'm sorry. I think. Yeah, it's a large set. Yeah, for sure. And we look at every one of them. So, there's a lot of, purely as like inspiring, kind of interesting research directions. To me, it's like super cool because, you have this mental model of like how a user is going to interact, and then you look at the data and they don't interact with that like that at all. You see all sorts of strange interactions. Some people, for example, are just playing around, and you can tell, right? And so you can imagine, they don't want to do a task. They're not cooking. So someone's just goofing around. So you might want to engage with that user quite differently than you engage with someone who's really like earnest and wants to make something. You can also tell, I think when it's like the 12-year-old, like the 12-year-old starts using a bunch of bad words. We see a lot of that. Not a lot of, we do see some of that. And so you want to still, want to guide them to have a good experience. You says semifinal means some teams were eliminated. Yeah. So we started out with 10. They split us up into 2 brackets of 5. It's just like March Madness. And the top teams, like the top 3 teams from each group advanced. And then they picked a few more advanced. So I don't know, maybe 10 went down to 8. Now 8 is probably going to go down to 5, something like this. So yeah, they are winnowing us down as we move forward. It's cutthroat. Yeah. It's cutthroat. It's tough. Okay, let's, and I can talk offline about, would we do this again? How about, this has been a lot of fun, but it's been real challenging. Because you can tell, I think you can tell from the talk, it's like, there is science and research, but there's a lot of engineering. There's a lot of bug fixing. There's a lot of, it's not a traditional like research project. So it has it has ups and downs. Okay, thanks for everyone for being here. Let's, so right now, I don't know if we're in the finals. No, I don't know. Semifinals end on Friday. And then we'll learn something probably by next week. So I'll let you know if we make it to the finals or not. So fingers crossed. We'll see what happens. Yeah, thanks. We need all the luck we can get. Okay, so let's talk about a few more topics and then we'll get out of here. So answering questions. So users ask questions a lot, okay? And so there's three kinds of questions answering approaches we have. So Amazon gives us something called a factoid QA model. And that would be if someone says, how tall is the Empire State Building? It's a factoid question. A lot of that can be learned out of Wikipedia, and they have their own model. So if a user asks a factoid-like question, you can deploy this model and it gives a response. Then you have what's called extractive versus abstractive. So extractive is basically kind of easier in the sense of if someone asks us something about a recipe, like the temperature or the cook time, we can go look in the recipe and then just find that piece and give it back to them. So if you say like, how long do I need to cook the lasagna for? Well, we have the recipe for lasagna. We'll say, oh, you need to cook it for 60 minutes. Abstractive, on the other hand, is we're trying to synthesize information that to give a response. And so I'll give you an example in a second. So like a factoid would be, and we do see this kind of stuff. Also keep in mind, like our users, they don't just follow the steps like we want them to, right? So we're in the middle of making lasagna and they can say, well, how many planets are in the galaxy? And if we say, I'm sorry, I don't know how to do that, they get mad, they give us a bad rating and they're gone. So this is where you're using a factoid responder. Extractive is we can go into all of those recipes, and this is like, it's typically called like slot filling. So you go into those recipes and we can analyze them. And you can basically say, oh, for lasagna, we just analyze and we say, what's the temperature? So you have like a temperature slot. What's the cook time slot? You have like an ingredients like set. What are all the ingredients? And you just if you just maintain all of that state, anytime anyone asks about any of those simple items, you can just do a lookup, right? What temperature of the oven? 375, because I already knew it, right? I just mapped it. That stuff is pretty easy. You also have like, you can do it not just from the recipes, but you can try to learn something from some like, Wikipedia or some richer knowledge base. So they may say, I don't have lemonade, right? So the recipe just mentions lemonade. It doesn't know about substitutes. And so separately, we have a substitutes knowledge base. So we collect, olive oil, butter, all these variations, different, vegetable oil. There's lots of things you can use in place of oil. In this case, for lemonade, you can also use, I guess, bottled lemon or lime juice. I'm not sure I would use white vinegar. But the idea is you can maintain, again, so this is still fairly simple if you've already pre-collected this information. When they say, I don't have lemonade, now we know that is a substitute intent. And then we can go do this lookup here and find a substitute. Yeah, so David says, is a singular task assumed? Yeah, this is a great question. Yeah, it is. So basically, we get on a task and they can stop it and switch out, but they're only doing one task at a time, not multitask. That would be like, I would rip my hair out if we had to do that. So yeah, there are some assumptions here. Another interesting point, yeah, kind of related to this, which is, sometimes users would ask things like they want to, back here on, I guess we don't say like how long it takes to cook, but this takes, let's say 20 minutes to cook. They would say, set a timer for 20 minutes. And so the idea is that they would assume we know how to make a timer. And at the time we did not know how to make a timer, right? But regular people want to use a timer. So we quickly realized we also needed to support doing a timer. What's weird about that is when you're in the Taskbot world, you're not in the regular Alexa world. And so sometimes users will say, play a song for me. That would be like another task. Like you're making dinner and you want a song playing. But so long as they're in with us, we can't play the song for them. That's not something that we do. That's more like generic Alexa. And so you can imagine some of your users get mad if they want to start music and you say, you can't, sorry, can't do it. That's sort of the extent of doing other tasks in parallel with what we're doing. The other kind of QA is like abstractive QA. And so this one, we actually are building like generative models. So the idea here is we have a bunch of text about, if you go like into WikiHow, you have the steps, but you have lots of text describing the steps. And so if someone says, can I put toys in a tub when bathing my dog? We're not just doing a lookup of yes, but use waterproof toys. We have to have a generative model that knows how to answer that. Okay. Can I wash my dog daily? It's recommended to bathe your dog when it stinks or every couple to few months. And so that's a different style. And we can talk about that offline, but that just give you a sense of like, this is challenging. It's another trick. I'm trying to think in terms of time. Just give me 1 second. I don't want to like bore you guys too much. Yeah, I think we can do this. Okay. Just to give you one idea of what we're doing in this QA space, is basically a lot of this stuff is like, there's something called like data augmentation. And so the idea is like, if we have like a passage of text and a bunch of answers, we want to like generate a question. Okay. And so the idea is you're sort of generating sort of synthetic questions and answers, which then allows you to improve your question answering systems. Okay. And so you want to have like really good like questions and answers. Okay. Because you really want to have high quality questions and answers. But the problem is like, we don't have good data sets for this stuff. And so if you look at the challenge down there, it's like, if we build some rules, like to do this in one domain, it doesn't generalize to a different domain. So it's like a really hard problem. So what we've been trying to do is figure out, can we generate lots and lots of really good question answer pairs that we can use as like a data augmentation strategy to help us like train a better model. Okay, so I just want to kind of give you the flavor of how this works. And just, I think this is kind of cool. It's something we call self-supervised answer selection. And so the idea is like, we have like, there's like this common kind of structure across lots and lots of like recipes or lots of tasks, right? Like you have to preheat the oven, you have to prepare a thing, you have to put a thing in the oven, you take it out of the oven. There's like a lot of this sort of structural information that's very common. But then there's some very like significant pieces that vary. Okay, so let me give you an example of what I'm talking about. Like here are like 1, 2, 3, 4, 5 different recipes: spaghetti, shrimp bisque, ... And you can see like they all mention in red a large skillet, a large pot, a something. Okay, and then you add to it what? You add in some amount of oil. Okay. We turn the heat to some particular medium or high or low. And then we do that for a certain amount of time in green, 3 to 5 minutes or 5 minutes. And so the idea is you can see there's like this structure throughout, right? And so kind of what we're trying to do right here is, again, I'm not gonna go into all the details, but sort of in the Bert world, the way they pre-train Bert is you mask out certain tokens and then you try to recover the right token. Okay, so the idea is like, after school, I ate a blank, and then so I ate a snack. I ate a taco. But you wouldn't. I didn't eat a cat, right? So the idea is you're kind of learning which words fit and which words don't fit. So we're doing something like that, which is we basically say like, I have this sentence, and then we try to mask out like some of the words. Okay, so we like try to make them disappear. And then we try to recover those. So you notice from the top, allow the oil to heat for 2 to 3 minutes on medium heat. So we basically mask them out. So the model can't see them. And then we try to build a model that can recover those components, 2 to 3 minutes and low. Okay. So if you follow what we're doing here, is we basically have like, we had some other penalties, but the idea is we have the original passage and we have this mechanism where we're trying to then recover the passage. Okay. And the hope is if we can train this over lots and lots and lots of these passages, then we're going to learn these really interesting representations. So when we do our question answering, if someone says like, how long do I heat the oil? Or what size pot do I need? We now have a model that can then generate a good answer based on this model that we've used to fill in the blanks here. This is something we're working on right now. I'm trying to give you the flavor that we have some cool stuff going on. Okay, last thing, in fact, we'll be finished in 5 minutes. Okay, last thing is about keeping the user engaged. So I think you've gotten the flavor of this as we've gone along, is like users are very not problematic, but users are finicky. They get mad at you, or they say crazy things, or it's hard to keep them like on task. So we have something called like empathic responder. And so the idea here is we're trying to understand the emotional aspects of our users and keep them like encouraged. So one thing we do get from Amazon is we get the words they say, right? They do also give us some, they also have off the voice signal, they do give us some attributes, like in terms, I think like sort of intensity or like highness or lowness of the voice that we looked at a little bit, but we're having a hard time making sense of it all. The idea is like if the user is getting angry at us and their voice is getting really high, or really, we could use that, which is sort of signal beyond just the words themselves. But the whole point here is we're trying to have not just respond, but sort of empathetically respond and try to understand our users a little bit better. So let me give you some examples. We have some very simple rules right now. Yeah, what if the user starts singing during the task? So long as they're talking to Alexa, and I'm not sure if we've heard, I'd have to ask our team. I don't know if we've heard singing, or at least we didn't know it was singing. They may have been singing and we screwed up in our response to them. Because I can always hear the words, but I guess presumably if we saw like some lyrics that we recognized, maybe we could make sense of that. So some of the things we're doing right now are like we're trying to like kind of conversationalize the steps. So basically when you talk to us, people get, I think, annoyed if you say, first step, do this, next step, do that, third step, do that. So one idea is to try to turn that into more like a conversation and make it feel a little friendlier. So instead of just saying step one, we say, okay, let's get started. And with Alexa, you can put in some emphasis. So you can put in, I forget the attributes, but like you can make it your voice, Alexa's voice, sound more excited, right? So you say, let's get started. Okay, first step. When they're about halfway done, you say, oh, we're halfway there. And then when they're on the last step, hey, last step, good job. Boom, 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 boom. David says, might you do any tone, intonation, intensity checks? Yeah, so we have done some very superficial look at that, but so far I think it's just been too noisy and we can't seem to make sense out of it. But certainly I think that's like a very viable way to kind of get a sense of if the conversation is heading in the wrong direction. So we're doing this, we kind of like empathetic responders, like we're trying to like engage with the user's emotions and kind of be a little encouraging here. Sometimes the user will say something like, I'm still working, because we'll say, okay, next step. And so we say, hey, no rush, take your time. I'm here whenever you need me. Okay, kind of give them a little encouragement, step back, and then they'll come back to us, okay, now I'm ready. Okay, step 4. And so we can resume the conversation. Another example, sometimes users will tell us their name. I mean, just unprompted. We don't ask for the name, but they'll just say, hi, I'm Caverlee. And so when we started this, you're not thinking about like, are they going to tell me their name? But now that we've seen that enough, if the user tells us their name, then we'll respond, hey, I'm happy you're here, Caverlee. Let's get started. Try to engage with them a little bit. Like these are all very simple rules. There's nothing fancy here, but it's the kind of things, again, as like a researcher, I've not really thought about like, how do I keep my users happy in this kind of example. We also have what we call like a bad conversation model. And this is a little bit to David, what you're getting at, which is basically we do have, we are looking at some aspects of the conversations as they evolve. And so like an example indicator would be if the user says the same thing like repeated, and we, for whatever reason, we can't help them. They say, I just want to make my lasagna. Say, I'm sorry, I can't, I just want to make my lasagna. If they repeat to us and other things, we do have a bad conversation model as the conversation is evolving. And so what we're trying to do there is rather than just frustrate you, and so then you're just mad, you give us a 1 and you leave, is to then intervene and say, I get it, like we're having a hard time here. I'm sorry about that. Give me another chance. Basically don't kill me. And just for reminding that we're still learning and come back, basically that's what we're trying to do there. Okay, that's our bad conversation model. Okay, and the future directions we're doing in this space, is, again, there's always more and more situations that are kind of new to us. So one thing I mentioned at the beginning is, we're not a social bot, but sometimes users do kind of want to chit chat while they're doing a task. And so we don't want to be a full-fledged chat bot, but we do want to have the capacity to have a little bit of chit chat. So you can imagine you're making lasagna and they say, oh, Alexa, do you know any good jokes? So we want to be able to be engaging while they're cooking the lasagna versus just saying, I'm sorry, I can't do that. No, step 4, step 5, step 6, things like that. We also need to really help our users who need more guidance, because a lot of times users will just say, like, I don't know what you're talking about. Sometimes, like with ingredients, we'll have some ingredient that's like a fancy ingredient, some kind of fancy herb. They don't say, I don't know what you're talking about. We need to do a better job of saying, oh, if you don't have this particular fancy herb, you can just use cilantro or whatever, something. Try to kind of not simplify, but try to be a little more understanding of our users. The other thing I mentioned before is like this conversationalizing. So if you go back and you think about, like, let me find that example, like these recipes we give them, or these steps. So like when they say, gather up any trash. Oh, Yunsuck says, maybe also add damage control. It's overcooked. Yeah. Yeah, exactly. Yeah. Kind of staying on top of really, and again, you can imagine all of this is really understanding the context. And basically what you discover as you build these things is that every time you feel like you've got a good handle on it, some user pushes beyond what you thought was possible. And it opens up all these new directions. So the last little thing we're looking at is this conversationalizing. So basically, remember, we're built on top of WikiHow. So WikiHow says, first step, gather up any trash. They say, well, tell me more about that. And we can say, if your trash can is full or the vanity is littered, but it's kind of boring and it's too long. And so basically what we're trying to do is build something that's more conversational, because these steps are meant to be read like on a website or on a phone. They're not designed to be spoken, right? And so you see a little bit of that conversationalizing. If you look, when we say things like, let's get started, or we're halfway there. This is like the beginning of conversationalizing. But we'd like to do is basically build like a transformation from those steps into more of conversational text. So if the step is, gather up any trash, look in the vanity and blah, blah, all this boring stuff, is like basically try to, rather than just sort of hard code this stuff, is like learn like a style transfer, or learn a way to turn that text into conversational text that has a little more like, it's a little less formal, it's a little more conversational. So that's something we're looking at right now. Super tricky. Okay. Thanks everyone for sticking around. Yeah, this is my last slide summary. Conversational AI, super exciting. I think there's a lot of challenges. I hope I gave you a sense of that. From my talk, I've focused a lot on engineering challenges, but let me tell you, there are lots of fundamental research challenges, and I have not really spoken about that. If you think this stuff is really interesting or cool, shoot me an email or ping me. A lot of interesting topics here. Last questions here. Reddy says, is there continuous feedback from these tasks from the users? So we do get repeated users, yes. So we do know how many times the user has interacted with us. And so what we get from them is we have the log of the conversation. They said, we said, they said, we said, if they rate us or not. And then Amazon also gives them a chance after the conversation is done to then give feedback as well. So they can say, I thought the Taskbot was really boring, and blah, 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 and we get that feedback as well. What I will say is, like, of this many users who interact with us, this many give us feedback. Seriously, this many rate us, this many give us feedback. So it really drops off. We do have users who come back. And so we'll see, oh, Reddy, this is your 10th time visiting us. And so what we could do, and what we're not doing, is we don't use any of that information. We don't like model and say, oh, welcome back. Or, like, we don't have a model of like the last 9 times you were here, you were making pasta. So we're not like using that information to know like what to recommend to you. So we just treat every interaction as if it's a brand new one. but in the sense of like, if it's your 10th time, like that's 10 times you can rate us, 10 times you can give us feedback. And we do see that kind of stuff. How do you know it's a return user? It's just one of the, Amazon just passes us that as like one of the little bits we get. You have like a unique user ID. I guess it's attached to the device you're using. It's all anonymized. We don't know your name. We don't know anything about you. But we do know it's like, oh, this user, ABC, XYZ, this is their 5th time to talk to us. Is the scoreboard visible? Every morning, like at 3 or 4 in the morning, they email us a scoreboard. Yes. I can't show it. I'm not allowed to share the scoreboard, but yeah, we do see every team's rating, average rating. We see a bunch of statistics about all the teams. Yeah. So you know where you are at every moment. And it's very nerve-wracking. Yeah, it's very stressful. I know for a lot of our team members. They want to squeeze us. So I'll talk about this offline, but kind of the style of this kind of project is just very unique and very different from anything I've ever done before. So again, I mentioned it has a lot of fun stuff, real users, but definitely has this very like, Amazon Drive, we have meetings with Amazon every week. Okay. Every week the team meets with Amazon. We have talks with them. We give slides, all the time. So they're very, very pushy, Amazon style. Yes. Yeah. If you're familiar with Amazon, very Amazon style. Yeah. So it's been kind of interesting. Yeah.